Okay, in this video we are going to derive a logarithmic expression for the inverse hyperbolic secant of x. And remember, if we say the inverse hyperbolic secant of x equals y, that's the same thing then as saying that the hyperbolic secant of y is equal to x. And here we sketched out the hyperbolic secant function. It looks like this. It is the inverse of the hyperbolic cosine function, which looks like a shallow parabola. So this is the reciprocal of this. We would expect that when this has a large y value, this would have a small y value. Then as this decreases to where y equals 1, its inverse function, the hyperbolic secant, is going to gradually increase to a maximum value of 1. Then as this assumes larger y values, this again will fall off to assume smaller y values. So the general shape of the hyperbolic secant function is what we would expect it to be. And over here we have the inverse hyperbolic secant function sketched out in blue, and that is the reciprocal of the inverse hyperbolic cosine function. And when this has large positive x values, we would expect its inverse to have a small positive x value, and then as this decreases to where x equals 1, its inverse, or its reciprocal, the inverse hyperbolic secant, that gradually increases to where x has its maximum value of 1. And then as this assumes more positive values of x, this again falls off. So for the inverse hyperbolic secant, x, it can be less than or equal to 1, and it can approach 0, but it's always going to be greater than 0. So let's go ahead and do what we did before, get an expression for this in logarithmic form, and we start off by using this equation here. So we're going to have 2 divided by e to the y plus e to the minus y equals x, or we can write this as 2 over e to the y plus 1 over e to the y equals x. And adding these, we have e to the 2y plus 1 divided by e to the y equals x. And we can put this e to the y upstairs in the numerator, so that will give us e to the y equals x. And if we multiply across, we'll have 2 times e to the y will equal x. Just multiplying across now. 2 times e to the y will equal x e to the 2y plus x. Well, if we put everything on one side of the equation, we will have this e x to the 2y minus this minus 2 e to the y plus x equals 0. And let's just divide both sides of the equation by x. So this is 1, this is 1, and here we're going to have 2 divided by x. And now we're all set to go ahead and use the quadratic formula to solve this for e to the y. So what do we get? E to the y equals minus b, which would be plus 2 over x, plus or minus square root of b squared, that's 4 over x squared, minus 4ac, so it looks like this is going to be minus 4 divided by 2 times a, that's just 2. So this will equal 2 over x plus or minus, we can factor the 4 out of this and take it to the outside, so we will have this 1 over x squared minus 1, everything is divided by 2, and of course these will cancel. Now 1 over x squared minus 1, that will be equal to 1 minus x squared divided by x squared. And we have this is in the square root sign, so we'd have the square root of this divided by the square root of that, which is just x. So finally we can say e to the y equals 1 over x plus or minus the square root of 1 minus x squared divided by x, or e to the y equals 1 plus the square root of 1 minus x squared divided by x, or e to the y will equal 1 minus the square root of 1 minus x squared divided by x. So since we use the quadratic formula, we get 2 answers for e to the y. And as we know, this always has to be positive. So let's check ourselves out here. Remember now, the maximum value that x can have is 1. That's always greater than 0. So x is always positive, and its maximum value is 1. So let's go to here. The maximum value x can have is 1. That would make this 0, and we would have e to the y equals 1. That's a positive value. And when x is less than 1 and greater than 0, that would still leave us a positive value. So this should be a valid expression. And over here, this is always positive. X is between 0 and 1. So if we take the natural log of both sides for both equations, here then we're going to have that y equals the natural log of 1 plus the square root of 1 minus x squared divided by x. And here we'll have the same thing, except we'll have minus. So we're going to write it like this, just 1 plus or minus. There's a problem though. If you look it up in textbooks, they have it as a natural log of 1 plus the square root quantity divided by x. Typically they don't include a minus sign. Maybe there's some reason for not doing it, but if there is, we can't think of it right now. So for the moment, we're going to leave it like this and include both possibilities. So going back up to here then, y is this, so let's just make some room. We're going to write it like this then, equals the natural log of 1 plus or minus the square root of 1 minus x squared divided by x. Perhaps in the future we'll have to revise this video. If you look up in textbooks, you see they have the plus sign, but they don't include the minus sign. We can't see any reason not to include it, so for the moment we're going to leave it like that. But anyway, that's it for this video. I think we have 2 more videos left regarding inverse hyperbolic functions and how we can write them in logarithmic form.